Hi there. So in this video, we're talking about standard deviation. Standard deviation tells us about how far data is spread from the middle. So it's still a measure of central tendency. And the way that we calculate it is first we have to find the mean. And then we take each data point and subtract it from the mean, which would give us a positive or negative number. So we square it to make sure that it's positive. We add up all of those squared differences and then divide by n, so we're finding some sort of mean, and then we take the square root at the very end to undo the squaring. So the answer that this gives us is a measure of the dispersion. And what we end up with is that what standard deviation tells us is that if a data set is normally distributed, then we end up with about 64% of data points are one standard deviation away from the mean. So we would take our mean, add and subtract this value, this standard deviation value, and in that range of numbers, so if we did our mean minus the standard deviation, and we use the symbol S, but your calculator uses sigma, so our x values, and then if we added the standard deviation to the mean, then this is going to be 60% of our x values, actually 64%, if it's normally distributed. Yeah, if it's not normally distributed, then standard deviation is still giving us sort of a measure of how far approximately data points are from the center. That's what we're measuring. So we can use this formula, but it's quite tedious. If we're going to use it by hand, we wouldn't even do it by hand, we would do it with a spreadsheet to do all these separate calculations. But really our calculator does it for us. And as it says here, with our calculator, we're looking at the sigma value. So let's look at our calculator. So here's our data set. We just have some ungrouped data. So I'm going to come into my calculator. I'm going to go into my stat, and I'm going to edit. Clear out my lists. Okay, so we've got 4, 6, 6.5, 7.2, 11.3. All right. So I'm going to do stat, calc. This is one bar stats, and we have no frequency list this time, so we're just going to clear that out. Okay, calculate. And our standard deviation value is this 2.40 when I round to 3 significant figures. So we're always using the sigma value. So sigma gives us our standard deviation, 3.40. So looking at these data points, they're spread pretty far apart. We've got 4 to 11.3 with only 5 data points. So from our mean, which is 7, so if I think about this, 7 plus 3.4 is going to give me 10.4, so close to this. 7 minus 3.4 would give me 2.6, so that's covering my data points. Same thing if we're doing our calculation. So here we would find our mean. So looking at these numbers, the mean from 1 to 5, let's see here, 6, 10, 15, divided by 5 is 3. It's our middle number. So now I would do mean minus data point, so 3 minus 1, and I would have to do that 11 times. Yeah, so I could just multiply that by the frequency. So just like we did for finding our grouped mean, this time we're having to multiply by the frequency, add up all the frequencies. And again, we're not even having to do it by hand because we could just do it in our calculator. Okay, so let's find that. Stat, edit. Okay, 11, 10, 5, 3, 1. This time we do have frequency data. That's in list 2. All right, and now our standard deviation 1.11. So standard deviation 1.11, and that of course is approximate. Okay. Again, interval data, we're just going to use the midpoint. So here we've got different lengths, and that's totally okay. Midpoint between 0 and 1 is 0.5, 1.5, 2.5, between 3 and 5 is 4, between 5 and 10, 7.5. Okay, 10, 15, 25, 40, 25, 5. Okay. Whoops, I obviously got very excited there. Standard deviation 2.234. So 2.23 if we're going to round to 3 significant figures. Okay, I'll come back and we'll talk about comparing the spread in the next video.